Hi guys, I'm here to discuss the Module 3 video on the normalization of databases. Specifically in the video, he takes one table and normalizes it using the first normal form, second normal form, third normal form, and fourth normal form. First normal form, he takes each attribute and makes sure that all the items in it are within their atomic domains. Then he puts it in the second normal form, where he makes sure each attribute has a functional dependency with the candidate key or primary key. And he does that by splitting out the tables into two separate tables and joining them on another table. Then he goes into the third normal form, where he ensures that each attribute is functionally dependent only on the candidate key. Then the fourth normal form, he makes sure that multi-value dependencies are taken care of, and he splits out one value with the candidate key into another table to make sure it's in the fourth normal form. I found the video rather disappointing, actually, after reading all of Chapter 8. It was not nearly as rigorous as the book is in defining the different normal forms. The book lays out exactly what a functional dependency is, and then goes into all the properties of functional dependency, almost making it into a new form of math that can define new functional dependencies from just a small set of functional dependencies, and then does all kinds of things with those to prove that or define that a table is in the proper normal form. In the book, he also goes into a decomposition algorithm where you can take a table, run it through this algorithm, and when it comes out the other side, it'll be in the third normal form, Boyce-Codd normal form, or fourth normal form. He lays out decomposition algorithms for each of those. I just didn't find that the video was very rigorous in its scientific explanation. It was kind of more on the practical end of getting a table in normal form. He didn't even really explicitly say what the functional dependencies were. He kind of just implied them in the video. Like, for instance, when he was converting the customer table to the second normal form, he just said that the price was not dependent upon the customer ID. Well, that was never stated formally in a functional dependency. He just assumed that was the case. Price could totally be functionally dependent upon the customer ID. If we were keeping something like a receipt or an invoice on the purchase, we could have a functional dependency there that would not cause that to be broken out into a separate table, as he did in the example video. Just interesting. I mean, I like seeing the practical side of breaking something out into normal form, or normalizing a table, but I really just didn't find that it was that scientific, and seeing we're learning how to apply computer science to database systems design. I thought it should be a little bit more formally defined. I was also kind of surprised. In the book, they talk about the second normal form very briefly. They talk more about the Boyce Codd normal form, which is like normal form 3.5. It's a little bit more strict than normal form 3. But the second normal form was talked about only briefly, only to say that it was obsolete or it's of historical value. Let me see if I can find it in the book here. Conspicuous by its absence from our discussion of normal forms is second normal form. We have not discussed it because it is of historical interest only. We simply define it and let you experiment with it in practice exercise 8.17. So that's about all they say about the second normal form in the book. So it's practically non-existent. I turn to practice exercise 8.17, and it says, it gives the formal definition of second normal form, and it says, show that every third normal form schema is in second normal form. So if you have it in third normal form, then it's automatically in second normal form, so you don't even need to worry about it. It says, show that every partial dependency is a transitive dependency. So I didn't go into actually proving that myself, but I just thought it was interesting he talked so much about second normal form. So I think that the one other video I saw uploaded as a discussion of the video talked about what reasons why you would not want to normalize a table. And the primary reason that I can see is for speed. If you want to have all the data there without doing a join on two separate tables, well, then you wouldn't want to normalize it. If it just depends on how you're going to use the database. If you're going to use it to just query on what would be the join if you normalized it, then you would want to just keep it unnormalized. But it makes it faster for accessing that kind of a query. But in most cases, you would want to have your database normalized. Thank you. Have a good day.